In question 28, we've got the volume of water in a dam being modelled by this equation V equals 7e to the power of kt, where t is in weeks and the volume is in megalitres. Now the volume of the dam is only checked once a week on Sundays, and we need to, in part A, find the initial volume of water in the dam. This is your key word. Initial means when time equals 0. So let's let time equal 0 and see what the volume is. We've got V equal to 7e to the power of, now if we're letting t equal 0, we've got 0 lots of k, and that's just going to give me 0. And this is 7 multiplied by 1, which is 7. Now, the question says find the initial volume of water, so leaving my answer as 7 is not quite good enough. I think it makes sense to say 7 megalitres, so that we've got our units there. Now, this is only worth 1, but it is in the section where you need to show your working. So even working as simple as just this part is probably enough, but set it out nicely so it's really straightforward in your mind what you're doing and why. In part B, it says after 5 weeks, the volume has fallen to 4.5 megalitres, and it started at 7 megalitres, remember, so it's dropped 2.5. Show that k equals this to 4 decimal places. Now, you don't want to just sub in this value of k to the formula and show that it lets the volume equal 4.5. That's not enough. That's using their answer to sort of verify that it actually works. With a show that question, you need to pretend that we've said, what is the value of k? And the advantage is, if you don't get this answer, you'll know that you've done something wrong. If you do get this answer, then it's the working steps that are going to get you the marks. And this one's worth 2 marks. Now, we know that after 5 weeks, that is when t equals 5, v equals 4.5, because we've been told that. So we can just sub those values in now and say 4.5 instead of the v is equal to 7 e to the power of kt, but if t is going to be 5, then really we have 5k. And that first step will get you 1 mark. Now we're trying to get the k by itself, so the first step, I think, is to try and get e to the power of 5k by itself by removing that 7 from both sides. So if we divide both sides by 7, then we'll have 4.5 over 7 here, and e to the 5k there. Now we've got e to the power of something is equal to something. So we can rewrite this as a logarithm. E to the power of 5k is equal to 4.5 over 7. Now you can figure out what 4.5 over 7 is if you like, but if it's a bit of a nasty decimal, it might be simpler just to write it like that, and then we don't have to reach for our calculator till the end. All right, how do we get k on its own now? Divide both sides by 5. So we write, therefore, k equals the log base e of 4.5 over 7, and you can either write over 5 like that, or you could put 1/5 out the front. Either way, at this point, now you can reach for your calculator, type it in, and you should get this number, which you'll then write down. And you know you've done it right because you've got the answer that they said you needed to show. So you'll probably get 1 mark for just starting out with something like this, and then another mark for actually rearranging so that it is to the power, so that k is the subject, and getting an expression that's either this one or one that's equivalent to it. Now in part B, where you used your calculator to find that value of k, I would at that point actually store it in my calculator by pressing Shift and then Store and then pressing that red A, so that then when I'm using that value of k later on, I can just recall it very quickly using alpha and then hitting that A again. In part C, it says how many full weeks will have passed before the volume is found to have dropped below 1 megalitre. So writing down my plan here, I want to let the volume be below 1 and then solve for t. So my volume is 7e to the kt, where I actually know k now. Now at this point I'd rather just write k, because during my working process k is so much easier to write than the log of all of this over 5. Okay, so it's easier to put that into my calculator and know that I have that, and then just call it k here. After all, the examiner will see that we've already found the value of k earlier on, so when we sub it in or use it, that will be fine. Now you could just sub in the value to 4 decimal places that you've been given, especially if you weren't able to do part B. don't count yourself out from part C. You can use their value in part B to continue part C. All right, so we're letting that be less than 1. Now we just need to solve this. So dividing both sides by 7 looks like a good first step to me. After that, we're trying to get the t by itself here. So one way to do it would be to take the log of both sides, which I could actually just do like this, saving myself a line. And then the power law tells me that the kt can actually come down the front here. So I could even write it like that, or I'll take another line and put all of that down here. Now, what is the log base e of e? It's just 1, isn't it? So at this point here, I can really say, oh, look, I've multiplied some stuff by 1, so I can kind of cross it out. So now I've got this. So then to get the t by itself, I need to divide by k. Now, don't forget that k is actually a negative number. So when you divide by k at this step, you're going to have to flip the sign. And you're going to get the natural log of 1/7 over that value of k, which we already know. So putting that into your calculator, we should come up with something around the order of 22 and a bit. I think it's 22.02, etc., etc. Now, we need to see how many full weeks will have passed. So if the volume goes below 1 megaliter at 22 and a bit weeks, we won't find that out until we come along at the end of the 23rd week. So therefore, 23 weeks. And I would finish like that.